Dear students, in this video we are going to see about the breakdown mechanism in gaseous dielectrics. The mechanism of breakdown in gaseous dielectrics. For the normal pressure and normal temperature, the gases are excellent insulators. The current conduction is of the order of 10 power minus 10 amps per centimeter square. This current conduction results from the ionization of air by cosmic radiation and the radioactive substances present in the atmosphere and the earth. At higher fields, charged particles may gain sufficient energy between the collision to cause ionization on impact with the neutral molecules. During elastic collision, a large part of the kinetic energy is transferred into potential energy by ionizing the molecule struck by the electron. Ionization by electron impact under strong electric field is the most important process leading to breakdown of the gases. We are going to see about the properties of a gaseous dielectric for high voltage application that should satisfy high dielectric strength, thermal stability and chemical inactivity towards materials of construction, non-flammability and physiological inertness and environmentally non-hazardous, low temperature of condensation, good heat transfer capability, ready available at moderate cost. These are the properties required for the good gases dielectrics used for the practical use. Now we are going to see about the electric breakdown takes place in gases. We are going to use that the gases dielectrics materials are air, nitrogen N2, carbon dioxide CO2, ferron CCl2F2, sulfur hexafluoride SF6. These are the materials we have to use it as a gases dielectrics. Now we are going to see about the gases breakdown. If we are going to apply for that higher voltages, current increases between the electrode in dielectric, then the breakdown will take place. What is meant by breakdown voltage? The maximum voltage applied to the insulation at the moment of breakdown, that voltage is nothing but breakdown voltage. We are going to take about the types of discharges, that is self-sustaining and non-self-sustaining. The theories talk about the gaseous medium for the breakdown in gases, that is Townsend theory and streamer theory. The first and foremost, the process for leading to breakdown will take place in the gaseous medium is nothing but ionization. What is meant by ionization? Ionization is the process that is liberating an electron from a gas molecule with the simultaneous production of a positive ion. This positive ion will induces in the gaseous medium that leads to the breakdown in the medium. There are various types of ionization process. This is nothing but the basic ionization process. Now we are going to see about that various types. First, the by collision. The second one is photoionization. The third one is secondary ionization. The fourth one is electron attachment process. These are the ionization process will take place. Now first we are going to see about the ionization by collision. That means what? The free electrons collides with the neutral gas molecule and gives rise to a new electron and positive ion. The free electron is collided with the neutral gas molecule that will gives a new electron, that is, and one positive ion. One electron plus one ion is induced. When the energy gained, that is epsilon, the gained energy during the travel between the collision exceed that ionization potential, that is Vi, which is the energy required to dislodge, remove the electron from its atomic cell, then ionization will take place. Now we are going to see about that how this will take place. We are going to take for the arrangement of the Townsend discharge setup. This is the setup for the Townsend discharge study for the ionization by collision. This is a study, experimental study shows the Townsend discharge. This setup consists of the two electrode, anode and cathode, are kept in the gas medium connected with the high voltage source via the ammeter and current limiting resistor to measure the current flow through the this setup. Basically the cathode is applied with the ultra voltage light, that the cathode is connected with the cathode is focused with the ultraviolet light. The ultraviolet light leads to the production of new electron and positive ion, that is the free electron is collide. If it is a pure gas medium, there is no production of ions and electron. So due to that electrode present in the gas medium, due to the effect of ultraviolet light, that is photon, the electrons and positive ion will be produced in the gaseous medium. That leads to the starting current of I naught. So here A represents the atom, A plus is the positive ion and E is electron. So electron produced at cathode by UV light falling on the cathode. The number of electron reaches to the anode is greater than the liberated from the cathode. So the free electron, while photon is absorbed by the metal, then the electron will be emitted. This shows the electron emission, that is free electron will be emitted. This is also explained about the structure of the ionization by collision. When the absorption of the energy gained by the electron, that will move towards the higher energy level. Once the excited electron, that will take for some time, then again return back to the original lower level, higher level energy level to lower level energy, that releases an emission, that means that releases or gives the emission. Next, photoionization. The photoionization involves the radiation of matter. When it occurs when the radiation energy absorbed by the atom exceeds ionization potential. That's why we have discussed in the previous slide. How the process will be takes place: excitation of the atom to a higher energy state, that continues absorption by the direct excitation of the atom, or dissociation of diatomic molecule or direct ionization, etc. Photoionization occurs with the radiation of 1250 Armstrong. Secondary ionization. It sustains a discharge after it is established due to ionization by previous process. There are three ways that the secondary ionization process will take place. That is electron emission due to positive ion impact, electron emission due to photons, electron emission due to metastable and neutral atoms. First we will see electron emission due to positive ion impact. Positive ion can cause emission of electrons from the cathode by giving up its kinetic energy on impact. If the total energy, that is sum of incident energy plus kinetic energy, is greater than twice the work function, then one electron will be ejected and a second electron will neutralize the ion. Second, electron emission due to photons, that is energy in the form of photons by applying UV light cause electron to escape from a metal. It will occur if Planck's velocity greater than the work function, then the incident will take place. Next, electron emission due to metastable and neutral atoms. Metastable excited particles whose lifetime is 10 power minus 3 is large compared to that of an ordinary one. That is, ordinary electron lifetime is 10 power minus 8. Electrons ejected due to the metastable atoms by sufficient energy yields to by nearly 100% for interaction of excited helium atom with the molybdenum, nickel or magnesium. Neutral, neutral atoms in the ground state also gives rise to second electrons if kinetic energy is high, that is above 1000 electron volt. Metastable atoms often lose their stored energy by collision with other atoms before they can radiate it. This is a absorption theory where we have to say that the absorption, spontaneous emission, and simulated emission of secondary ionization process. Then the third one is electron attachment process. The types of collision in which electron may become attached to atoms or molecules to form negative ions are called attachment collisions. Electron attachment process depends upon the energy of the electron and the nature of the gas, and it is a very important one. All electrically insulating gases O2, CO2, Cl2, F2, C2, F6, C3, F8, C4, F10 and CCl2, F2 and SF6 exhibits its property. An electron attachment process can be represented as atom plus electron affinity, that gives a negative ion plus electron affinity plus attachment electron. In the, in the attaching or insulating gases, the atom or molecules have vacancies in their outermost shell and therefore they have affinity, that is attraction for free electrons. This process, the electron attachment process, is very important for the removal of free electrons present in the ionized gas when arc interruption occurs in a gas insulated switchgear. It is especially used for the removal of free electron in the gas insulated switchgear system. It is very most important. First we are going to see about that how that the electron, that is breakdown mechanism, will take place, that will described by the Townsend theory. We are going to see about the Townsend theory, the Townsend first ionization coefficient. First we have to take for the consideration of parallel capacitor having a gas as an insulating medium and separated by a distance d. When no electric field is set up between the plates, a state of equilibrium exists between the state of electron and a positive ion generation due to the decay process. This state of equilibrium will be disturbed the moment a high electric field is applied. The variation of current as a function of voltage was studied by Townsend. He found that the current at the first is increased proportionally as the voltage is increased and then remain constant at I naught, which correspond to the saturation current. This is the variation of function, that is variation of current as a function of voltage. The Townsend introduced a coefficient alpha, that is first ionization coefficient, that alpha depends upon the gas pressure P and ratio of electric field intensity to the pressure, known as Townsend first ionization coefficient, and it is defined as the number of electrons produced by an electron per unit length of path in the direction of field. Now we are going to take for the study of this, let n naught be the number of electrons leaving the cathode, and when these have moved towards through a distance of d from the cathode, these become n. When one electron collides with the neutral particle, a positive ion and n electrons are formed according to ionization process. This is called ionization by collision. Let A be the average number of ionization collision made by, that means alpha, by an electron per centimeter travel in the direction of the field at any distance x from the cathode. Let the number of electron be the nx. Now when these n electrons move through a distance, dx produces additional dn electron due to collision. Therefore dn equal to alpha into n into dx. We have to take further simplification. We have to apply further boundary condition at x is equal to 0, n is equal to n naught. Therefore we can get n is equal to n naught into e power alpha d. At x is equal to d for the secondary boundary condition, n is equal to n naught into alpha d, we are getting this value. Therefore, this is in terms of, we are going to make it as a change as current for number of electron into current. I is equal to I naught into e power alpha d. Therefore, the average current in the gap, which is equal to the number of electron travel per second, will be I is equal to I naught into e power alpha d. The term here, e power alpha d, represents the electron avalanche, and it represents the number of electrons produced by one electron in traveling from cathode to anode. Next, the same Townsend theory represents the secondary ionization coefficient. The same parallel plate structure. The additional current maybe takes place due to the presence of positive ion and photon. The amplification of the electron e power alpha d is occurring in the field. The probability of adding new electrons being liberated in the gap. The secondary ionization coefficient is represented by gamma is defined as the net number of secondary electrons SE produced per instant positive ion, photon, excited particle or metastable particle, and the total value of G is the sum of individual coefficients. That is sum of gamma 1, gamma 2, gamma 3. That is due to the positive ion, photon and excited particles. This is the Townsend procedure for the current growth lead to the breakdown. The currents keep on increasing the value, reaches to the breakdown. Let us assume n naught s is the number of secondary electrons produced due to the secondary ionization process. Let n naught double dash represent the total number of electrons leaving the cathode. Then n naught double dash equal to n naught plus n naught dash. That is the total number of electrons. N reaches the anode. Anode becomes n is equal to n naught double dash e power alpha d. That is equal to n naught plus n naught dash into e power alpha d. We have to eliminate these terms. We can get the arrival of I is equal to I naught e power alpha d divided by 1 minus gamma into e power alpha d minus 1. This equation gives the total average current in the gap before the occurrence of breakdown. So this is the current expression, the total current in the gap before leads to the breakdown. We are considered for that the current become infinite if 1 minus gamma into e power alpha d minus 1 is equal to 0. So we can get this expression gamma into e power alpha d minus 1 is equal to 1, that is also equal to 1. Since normally e power alpha d is greater than 1. So the condition e power gamma into e power alpha d is equal to 1 defines the condition for beginning of the spark and is known as the Townsend criteria for spark breakdown or Townsend breakdown criterion. We are applying that voltage, keep on increasing the voltage proportionately the current value is also, then initial current is keep on increasing and saturating that value. Once reaches to that value, that is e power gamma d, e power alpha d into gamma, the value is gradually increases that reaches the exponential value I is equal to I naught e power alpha d, that reaches the saturated value. Above that value, that leads to the breakdown. This is the condition for the Townsend criteria for breakdown. Hope all of you understand about the Townsend theory. Thank you.